Okay, let's dive into this. Welcome to The Explainer. Today we're taking a look at a literal cosmic mystery, and it's one of the most profound puzzles in all of physics, the problem of quantum gravity. You see, for decades now, the greatest minds on the planet have been trying to unite the physics of the incredibly massive with the physics of the incredibly tiny. And for decades, they've just hit a massive brick wall. But a recent, totally groundbreaking 2026 study from physicists at NYU and Caltech has taken a completely fresh approach to this problem. They decided to treat the fundamental laws of reality like a giant logic puzzle, and the solution they found is, well, it's absolutely fascinating.
So, what exactly happens when our absolute best theories just stop working? To understand this breakthrough, we first really need to visit a bit of a cosmic crime scene. Right now, humanity has two incredibly successful frameworks for understanding the universe. First, we have general relativity. That's the one that brilliantly explains how gravity behaves on the largest scales we can see. We're talking galaxies, stars, planets, the whole shebang. And on the flip side, we have quantum mechanics, which perfectly describes the absolute smallest scales of the universe, atoms, subatomic particles, and the tiny forces that bind them together. The problem? Well, when physicists try to calculate how gravity behaves down in that quantum realm at extreme energies, our best theories completely break down. They simply refuse to work together.
The root of this conflict really comes down to how each theory views the fabric of reality itself. General relativity treats spacetime as this smooth, continuous geometric fabric. It's elegant, it's continuous, and most importantly, it's predictable. Quantum mechanics, on the other hand, is completely ruled by the uncertainty principle. When you zoom way into the absolute smallest possible scales, what physicists call the Planck scale, physical quantities are subject to these violent, chaotic quantum fluctuations. It becomes this turbulent quantum foam, and you just cannot have a perfectly smooth, predictable manifold while simultaneously having chaotic, unpredictable quantum fluctuations. The two concepts are literally fundamentally incompatible.
So, what happens when you just try to force these incompatible theories together anyway? You get what physicists absolutely dread the most: mathematical infinities. When scientists try to use the tools of general relativity to figure out scattering amplitudes, which is basically a fancy way of describing the probabilities of what happens when particles collide at higher and higher energies, the equations literally blow up. They just yield infinite results. And in mathematical terms, an infinity in this context basically means the results are completely meaningless. It's the math's way of telling us that the theory is broken, and that we are clearly missing a fundamental piece of the puzzle. Now, the prime suspect behind these meaningless infinities is the very concept of the point particle. Traditional particle physics treats fundamental particles as zero-dimensional points. And if you think about it, a zero-dimensional point particle has literally no spatial extent. It takes up no space. So this means that when these zero-dimensional particles interact, that interaction is infinitely localized. It happens at a mathematical point of absolute zero size, which forces the quantum fluctuations at that precise location to become infinitely large. And boom, that's what generates those nasty mathematical divergences we just talked about.
And this brilliantly illustrates what happens when we totally change the game. Look what happens when we replace that zero-dimensional point with a one-dimensional, finite loop, a string. Because a string actually has physical length, when two strings interact, that interaction isn't happening at a singular, concentrated mathematical point anymore. The interaction is smeared out over a finite region of space. It's a really simple but profound geometric change, and it entirely tames those violent quantum fluctuations and eliminates the mathematical infinities, all without destroying the underlying structure of the physics. Which brings us to the incredible 2026 breakthrough. Instead of just guessing at the incredibly complex math required to build a full string theory from the top down, researchers from NYU, Caltech, and the Institut de Física d'Altas Energies decided to try an innovative, back-to-basics method. It's called the bootstrap approach. Now, the bootstrap method means you don't start with a massive, complex theory. Instead, you start with just a few basic, heavily constrained assumptions that you strongly believe to be fundamentally true about the universe, and then you just follow the math to see what physical laws inevitably emerge from those assumptions. The researchers themselves described this method beautifully. They noted that their bootstrap approach is actually a lot like a Sudoku puzzle. If you've ever played Sudoku, you know the drill. You start with a grid and just a few really strict rules about how numbers can be placed. You aren't guessing randomly, right? You're using pure logic to eliminate impossibilities until you find the single, unique solution to the puzzle. These physicists did exactly this, but their grid was literally the universe, and their numbers were the laws of physics governing high-energy particle scattering.
Let's move to the rules and see how this all builds, because two strict mathematical constraints form the entire foundation of their cosmic Sudoku. First, they enforced a rule they called ultra-softness. This mathematically requires the interactions have to soften or smear out at extremely high energies, which is what helps avoid those nasty infinities. Second, they enforce something called the minimal zero of particle behavior. This is a rule positing that particles absolutely must move and interact in the smoothest way mathematically possible. So they set up the math to describe just these two assumptions, and then they asked, okay, what kind of universe actually satisfies these rules?
The answer they got back was staggering. By enforcing just those two logical constraints, ultra-soft interactions at high energies and smoothly moving particles, the mathematics yielded exactly one functioning framework. As Caltech professor Cliff Ching put it perfectly, the strings just fell out. Think about that for a second. They didn't assume string theory existed when they started the math. String theory just emerged, entirely on its own, as the only mathematically viable solution to their two basic constraints.
Now, what's really interesting about this is the sheer level of detail that naturally emerged from the equations. The math didn't just suggest some vague, high-level idea of strings, it automatically produced the defining hallmarks of string theory. The equations yielded the full spectrum of particle masses and spins, exactly as string theory defines them. It produced their detailed interaction strengths. It even automatically generated the famous infinite tower of massive spinning particles. Those are the fundamental harmonics of the vibrating strings that string theory relies on to explain all the varied particles we see in the universe. It was all right there.
Grant N. Remen, a postdoctoral fellow at NYU and a co-author of the study, really emphasized this incredible result. He stated that the precise details of string theory emerged automatically. Now, this new 2026 paper actually built on some previous work they did back in 2024, but this time they used even less stringent technical assumptions. The fact that arriving at string theory is inevitable from even fewer mathematical constraints, that strongly suggests that string theory isn't just some clever human invention. It really appears to be a mathematical inevitability derived from almost nothing.
So the crucial point we need to take away from this is this. We obviously do not yet have experimental physical proof of string theory. We just can't build a microscope powerful enough to physically see a string. But theoretically, this bootstrap approach is incredibly suggestive. These two general, basic assumptions about how the universe should operate could have theoretically yielded an infinite number of mathematical solutions, but they didn't. They yielded exactly one. The fact that the universe's behavior acts as this highly constrained logic puzzle with a single, unique answer is a profound hint that we are absolutely on the right track.
Which leaves us with a final and pretty provocative thought. By mathematically eliminating the infinities that have plagued quantum gravity for nearly a century, these researchers have shown that string theory might actually be the only logical way a universe can function without breaking its own rules. If string theory truly is the universe's only unique mathematical solution, are we simply waiting for our technology to catch up to what the math has already proven? It's an incredible testament to the elegance of the cosmos. And honestly, it proves that sometimes, to solve the biggest mysteries in reality, you just need to follow the rules of the puzzle.